this video, we move to the number 3 program challenge for chapter 7, solving calculus problem. So this challenge is named as the area between two curves. So let's see what's the contents of that. In the right of the book is we have learned within the let's put our mind map here. So when we do this mind map learning, if I put that in the left, we within the 7 we learn how to find the integral of a function. So I make a linkage here. So actually from this sub-chapter we learned this formula. So that is the standard function integral formula. Express the area enclosed by the function with the xl between x and a and b. So that is our you can see that's 4 edge, but normally this fx is not necessarily be our the straight line. So it can be any the shape or can be a curve. So but anyway the result will be that area between these four kind of this the one dimension shape we can see, so line or curve. The area between two curves is defined as the function deduct by another function. So normally, we assume the fx is above gx. So that's just from the natural. The meaning is the area should be more than 0. But we during our testing we can do is if we make gx deduct by fx, what's that meaning in this integral? So the formula is very direct. So if I'm given the two functions, like this fx is this x is a straight line, and gx is x the square 2 is this curve. Then if I do fx the minus gx on every these x values, and I put is a and b as our boundary, so that can be our the area between the fx and gx and a and b. So our challenge here is to write the program allow user to input now it's 2 single variable functions instead of 1, and the variable will be point to x, and then print the enclosed area between 2. And the program should make it clear that the first function entered should be the upper function, and it should also ask for the value of x between and which can find the area. So let's go to our coding. So that is the number 3. So we can do this from scratch. So don't make that copy from others. So area between two curves. So let's make our purpose. Yeah, between two given curves, we calculate those areas. Yeah, we have our header done. So let's think about this. What's the roughly? So you may not import all the library or the class. You can wait is when you start to use something, then you will load that. So definitely we will have SymPy and import integral. So that is the must one, and we should have a symbol. And if we want to check these functions validated, so we need to use this simplify, and as well as we will have this simplify arrow. So simplify arrow is the S and E are the capital. So we start is we have our roughly the initial class on hand. So we make our primary code part. So we will ask people to input the two functions. So let's input first is enter the upper. So as mentioned, is we should ask let user to know is which is his enter the upper. But we will also try to calculate using g minus f to see what happened. So one variable. So and we have this one, and we will make function g, and that's the lower. Also the one function. So once we have this, we can try the f is simplified f, g is simplified g, except simplify arrow. Then we will print one of your input functions is invalid. Yeah, so I think we don't need to indicate which. We can add more, a little more complex the checking. So if f is this, then we see that give our indicator. If y g, then but that is too much. Those are not our key the parts for the program. So then this else, what we will do is we should have a variable the user need to input. So we ask the user to enter the variable. Then we will put this variable is equal to symbol. Now is var. And what we another we need is we need A and B, right? So we put is A is the left, B is the right. So and we put is a float, the input, enter the lower bound or boundary of the enclosed region. And another is B. B is the upper. And then we can call is the if we did that is the our area is let's see. So we find this our area. So found area. We see just give area is we create our find area. So let's think about this the argument we need to transfer. So they need at least function x, function g, and then the variable if that's x or no matter which symbol, and they need A and B. So that means we should transfer the 5 arguments, and then we can have the last is the area enclosed between the function. Let's see, this the first function and second function is the last. So let's say our format. We should have this fg and then the area. Yeah, I think that's the main structure. Then let's focus about is to deal with our function. So we define that is the find area. So we get 5 arguments, A and B. So how we can use that? So it's very easy. So integral is the just we make this function. So we can directly make this function divide deduct. So it's we just see is area is equal to integral, and here we put is f minus g, and our variable with this the tuple, and give a bound value a and b, and we don't forget about this dot. Then we return area. So I think it's now we have done this, and let's see. So if I put this area 1, area 2, as I mentioned, this let's do our test is g minus f. So we will have 2. So then, so 3. So let's see. So whether we will get errors. Yeah. So now we also ask g minus f. So and we see what will happen. So I think it's recent videos I found this analysis getting slower and slower. So that is interesting. So configure do not call the runner py length. I suppose it's, that is by some this extension, but actually does not impact our the running. So first, upper function. So upper function is just x. We can see the upper function is just x. Let's see. So, and the lower function is x times x, and the variable is x. So if I put this 0 to 1, so this 0 is the float, and to 1. So you can see here, if I use f minus g, so I will get positive the areas. If I use g minus x, I will get negative. So I should say in the geometry, this second one is no meaning or no definition. We don't see what's meanings for our negative area. But from the this algebra, or from the purely the mathematical ways, it's definitely available or valid. So that's why it's we don't have a limitation from the math to do this lower divide minus the upper. But from the author mentioned is we are putting that into the context of the geometry. So that is a real curve, and we want to see the delta of the area. So you'd better to indicate is or try your program only do this upper curve minus lower curve. So, but I will leave both here. So just to let you know, it is not generate a programming error. And let's do another test with some other the functions. If I put that x plus 1, if you read the solution paper, the author mentioned is they gave you another this kind of the functions, and x we put it 0. So sorry, I didn't put the b. So our program is very fragile, so you can see if you miss any arguments, it will dead. No, it also have that, so symbol exp. So if we do this, we should have the exp, so import. So let's not bother by that. So let's do some like this. We have this complex the formulas times x is 3 plus maybe 12. So that is, I don't know it's upper or lower. So that is the issue. So I will put is x 2 times x 3. plus 2, maybe 3 times x squared minus 13. So then x is that, and I put is 1 to 5. So this definitely will be able to calculate it. So here is looks like is the first f is upper because first is positive, and then second is the negative. So, but it's fine is they give you this kind of the calculation anyway. So I hope it's from this you can extend your ideas on the integral. So it's not we can calculate the delta between two integrals or two these shapes, and then you get those the middle or this between area. So that's conclude this video. So next video we will try to find the length of a curve. So it's this on the this curve edge. We find how length of that. So see you in the next video. Bye for now.